Hi everyone. Today's topic is calculate N or C number and APF of simple cubic crystal structure. Shortly it is called as SC crystal structure. N denotes number of atoms per unit cell or effective number. R is the atomic radius. C denotes coordination number and APF is called as atomic packing factor. Now, a simple cubic crystal structure is shown in the diagram. It consists of 8 corner atoms. The arrangement of atoms is in such a way that the adjacent corner atoms touches each other, whereas the diagonally they are not connected. So it is shown in this diagram. So in a two-dimensional way it is drawn. Let A be the side of the simple cubic unit cell. Here the corner atoms are touching each other, whereas diagonally they are not connected. A is the side of the simple cubic unit cell. Now we are going to calculate how many number of atoms are present in the unit cell. Now N can be calculated by the definition for number of atoms per unit cell is the total number of atoms present in the unit cell or shared among the unit cells. Here the sharing can be explained using this diagram. Here you can see there are 8 unit cells of the simple cubic crystal structure is shown here. Below you can see 4 unit cells. Above there is one more stack of 4 unit cells. All the corners consist of one atom. Here the sharing is, consider the center atom. This corner atom is shared by 1, 2, 3, 4, as well as in the above stack also 1, 2, 3, 4. That is, one corner atom is shared by 8 adjacent unit cells. So this is the diagram which explains about the sharing of atoms in the simple cubic crystal structure, which holds only 8 corner atoms. Each corner has an atom in it. So one corner atom is taken here. This is shared by 1, 2, 3, 4 as well as 5, 6, 7, 8. One above the other. So 4 in the below stack, 4 in the above stack. This one corner atom is shared by 8 adjacent unit cells. Therefore, so number of atoms per unit cell can be calculated by one corner atom is shared by 8 adjacent unit cells. There are 8 corner atoms totally in one simple cubic unit cell. Therefore, after sharing, the value of N, effective number or number of atoms per unit cell for SC, simple cubic crystal structure, is 1. So effective number of SC is 1. Now atomic radius. Atomic radius can be taken by, in this diagram, A is the side of the unit cell and these are the corner atoms. I am drawing the corner atom. So these two are considered as nearest neighbors. That is, they have direct contact with each other. From the center towards the circumference, it is radius. Similar way, from the center towards the circumference of this spherical atom, it is radius. Therefore, 2R is equal to A, where A is the cube edge or side of the cube. R is equal to A by 2. Therefore, atomic radius of the simple cubic crystal structure is half of the nearest neighboring distance. That is, the distance between the centers of the two nearest neighboring atoms. Nearest neighboring atoms should have direct contact with each other. So, for simple cubic unit cell, the atomic radius is A by 2. Then, for coordination number, C number, we have taken 8 unit cells. The definition for coordination number is the total number of nearest neighboring atom surrounding a particular atom. So, it is called as coordination number. Consider this particular reference atom, corner atom, as X. The coordination number for this particular atom is, in this particular plane, the atom 1, atom 2, atom 3 and atom 4 are at a distance of A. They are at a distance of A, equidistant from the reference atom. Whereas this particular atom is far away from this atom because this is A and this is A. All these are side of the cube. So this should be at a distance of root 2A. So root 2A is 1.414 of A, whereas these corner atoms, which are considered as nearest neighbors, are at 1A distance. So coordination number for this particular simple cubic crystal structure is, one reference atom should be considered, and then to this particular reference atom, how many number of equidistant nearest neighbors are there. We need to calculate it. For this 1, 2, 3, 4, all these 4 corner atoms are at a distance A, and then in the above stack, this is also at a distance A, atom 5. Similar way, in the below stack, atom number 6 is also at a distance A. So, the coordination number for simple cubic crystal structure is 6. So, C number for SC is 6. That is 1, 2, 3, 4. These are at a distance of A. Similarly, 5 in the above stack and 6 in the below stack. These two are also at the same distance A, whereas remaining atoms to this reference atom, they will be far away from this atom more than at a distance of A. If you consider any atom also as a reference atom, only 6 will be considered as the nearest neighbors. That is, for this 1, 2, 3, 4, 5, as well as in the above stack, there will be one more atom will be there. So coordination number is 6. And then atomic packing factor, APF. The formula for APF is the volume occupied by total number of atoms in the unit cell to the total volume of the unit cell. So it is the ratio of atomic packing factor, how atoms are arranged in this simple cubical crystal structure, can be defined as the ratio of the volume of the total number of atoms in the unit cell to the total volume of the unit cell. So the total volume of the unit cell in the denominator, since it is a cubical structure, A is the side of the cube, so volume can be taken as side into side into side. Therefore, A cube is the volume, whereas the volume of total number of atoms present in the unit cell is, that is, how many number of atoms are present in the simple cubic crystal structure. into the volume of one atom will give you the total volume of the atoms in this simple cubic unit cell. N for SC is 1, and then the volume of a spherical atom is considered as a sphere, therefore 4 by 3 pi r cube. R is the radius of the atom divided by a cube. Now we know that the radius of the atom is a by 2. Therefore a is equal to 2r. Therefore a cube is equal to 2r the whole cube. So here a is equal to 2r, a cube is equal to 2r the whole cube, which is equal to 8r cube. Now we are going to substitute that here. Therefore in the numerator we have 4 by 3 pi r cube, and then a cube is taken as 8 r cube because a is equal to 2r. Then 4 twice r cube get cancelled off, so we get pi, and 3 into 2 we get 6. Therefore atomic packing factor of simple cubic crystal structure is pi divided by 6. If we calculate this, we get 0.52. That is, in the simple cubic unit cell, 52% is packed with atoms and the remaining 48% is vacancy. So here we have calculated the number of atoms per unit cell of SC as 1, atomic radius is equal to a by 2, coordination number as 6, and atomic packing factor of simple cubic crystal structure is 0.52 as packing fraction, otherwise atomic packing factor is 52%.